Ellipses. An ellipse is the set of all points P in a plane such that the sum of the distances between P and two fixed points called the foci is a constant. So what this means is we have our ellipse, which essentially is an oval type shape. We have two foci in the center, and we pick any point on our ellipse. We find the first distance and the second distance, you add them together, and you get a number. Then if you find any other point on the ellipse, find the first distance, find the second distance, add those together, you're going to get the same number. Then if you keep doing that the whole way around, you're going to get an ellipse. Now, the line through the foci intersects the ellipse at two vertices. The major axis joins the vertices, and its midpoint is the ellipse's center. So what that means is out here you have a vertice, you have a vertice. You then connect with a horizontal line, in this case, the foci and the vertices, and that's your major axis. Right in the middle is your center. The line perpendicular to the major axis at the center intersects the ellipse at the two co-vertices, which are joined by the minor axis. So then, if we come up here, we have two more vertices. Those are your co-vertices. And when you connect those through your center, that's your minor axis. Notice that the major axis is the longer one. The minor axis is the shorter one. And if you look at the two diagrams below, that can flip. So in the first one over here on the left, your major axis is the horizontal, versus the one over here on the right, your major axis is the vertical. So it's always your longer one. And then the longer one also has your foci on it. You then have two equations if your ellipse is centered at the origin. Take a very, very close look at these. Notice that the x squared is the first variable, the y squared is the second variable. Do you notice, though, that the a and the b flip-flop and they change? So based on where your major and minor axis are, a is always your larger number. So a is always going to be larger than b, and this is important. The other thing to keep in mind is that if a is larger and it's sitting below the x, this tells you that your major axis is on the x-axis. If your a is larger and it's sitting below the y, that tells you that your y-axis is your major axis. The other biggie here is that this has to equal 1. Has to. If it doesn't equal 1, then this is not the standard form equation of an ellipse. So, standard equation of an ellipse with the center at the origin, kind of what we already went over. A is always going to be greater than B, and then we've always got this equal to 1. The other thing is, because we're talking about the sum of the distances, this always has to be an addition sign. If it's not an addition sign, you're actually talking about something else called a hyperbola, which will be coming up later. Last but not least, the major and minor axes are of lengths 2a and 2b, respectively, where a is greater than b, which is greater than 0. The foci of the ellipse lie on the major axis at a distance of c units from the center, where c squared equals a squared minus b squared. And that's really, really, really important. Now, before we move on, let's say we have an ellipse like this. We have a center right here. We know that we have an a value. So we go at a this way to find a vertice. We go at a this way to find a vertice. That's why that major axis is 2a, because you go both ways. And then same thing, if you have a co-vertice, you go up b, you go down b, which means that's why your minor axis is 2b. Then if you want to find your foci, which are sitting somewhere in here along your major axis, you're going to use this formula. Example 1, graphing the equation of an ellipse. Graph the equation of each ellipse, identify the vertices, the co-vertices, and the foci. Now, the first thing I'm looking for is I'm going to be looking for some a and b values, and keep in mind that a is always larger than b. So in this case, a is sitting right here, b is sitting right here. I also know that my center is going to be at 0, 0, because there's nothing along with the x and there's nothing along with the y. Now, sitting right here, this is actually, this 64 is a squared. So if I want to find just a, you have to take the square root of 64, which is 8. Now, that tells me how to go find my vertices. And my vertices, because this is below the y, I'm going to stay along the y-axis. And from my center, I'm going to go up 8, and I'm going to go down 8. So my vertices are at 0, plus or minus 8. If you don't like that, you can write 0, 8 and 0, negative 8. It doesn't matter. Now my co-vertices, I have to go find my b, which in this case, I'm going to take the square root of 49, which is 7. Now notice that this is on my x, so I'm going to keep that on my x-axis. So I'm going to go out 7 and out 7, which means my co-vertices are at plus or minus 7, 0. Then we have to identify our foci. Keep in mind your foci are laying on your major axis, and your major axis here is the vertical one that has your vertices on it. If I want to find my foci, I'm going to use the relationship that c squared equals a squared minus b squared. So c squared, I know that a squared is 64, minus b squared, which I know is 49. C squared equals 15. So I know that c is plus or minus the square root of 15. Now, for the sake of actually labeling your foci, we're going to leave that. But if we want to actually figure out where that is on the graph, I'm going to approximate it, and the square root of 15 is roughly 3.873. Which tells me from my center, I'm going to go up 3.8-ish and down 3.8-ish, which is where my foci are. If I'm then going to list that, that's at 0 plus or minus the square root of 15. So there we have everything labeled. The last thing we have to do is we actually have to graph it. Try your best. I usually do a horrible job here. That looks more like a circle than it does an ellipse. But you just go, you connect your major vertices or your vertices with your co-vertices and try to make it as much of an ellipse as you can. Letter B, x squared plus 4y squared equals 36. Now, before we start graphing, there is a major issue here. And that major issue is that this does not equal 1. This is not the standard form equation of an ellipse until that is equal to 1. So the question becomes, well, what do we do to get it to equal 1? And the answer is, we're going to divide everything by 36. So if I divide that by 36, that will be 1. But that means I have to divide this by 36, and I have to divide that by 36. On the first one, I'm going to have x squared over 36 plus 4 and 36 are going to simplify to 1/9. So y squared over 9 equals 1. Now that looks more to me like our standard form equation. It's equal to 1, we're adding, we're good to go. A and B values. We also have a center at the origin. A is always the larger one, so this guy's going to be A, this guy's going to be B. Remember, if you actually want to find A, you have to take the square root, which is going to give us 6. Take the square root, which is going to give us 3. The A value this time is under the X, so we're going to keep along the X axis, and I'm going to go out 6, 1, 2, 3, 4, 5, 6. And I'm going to go out 6, 1, 2, 3, 4, 5, 6. So my vertices are at plus or minus 6, 0. My co-vertices, which are my B, which is below the Y, so we're going to go up 3, and we're going to go down 3. So then my co-vertices are at 0, plus or minus 3. Then the last thing we're going to have to find are our foci. In order to do that, I'm going to go back to c squared equals a squared minus b squared, we know that a squared was the 36 minus the b squared was 9. 36 minus 9 is 27. If we take the square root of that, we're going to get 3 root 3. Now again, when we list the vertices, we're going to use 3 root 3, but for the sake of getting them on the graph, that's roughly 5.196. So on your major axis, we're going to go out 5.1-ish, 5.2-ish in both directions. So those are our foci. And then when we list those, they are going to be at plus or minus 3 root 3, comma 0. Then the last thing we have to do is graph this thing. Again, try your best. Try to make it look as much like an oval or an ellipse as you can. There you go.